Alright, welcome to my glitch sound design tutorial. This will probably be the first of a series of videos just because there is so much ground to cover. There's so many different ways of making glitchy sounds. But it's just something I've been working with a lot recently, and I wanted to share it with anyone who's interested. I'll primarily be using phase plant because it's generally my synth of choice, especially because of its modulation system, which is really conducive to glitch sound design. Works really well for it. But any sort of like modern flexible synthesizer, like Vital, Surge XT, Serum, although Serum wouldn't be my first pick because I don't really like its random modulation, but you still absolutely could use it, just not, it's not my favorite. Polygon 2, which is kind of tailor-made for glitch sound design. Concept by Krotos. I don't know, there are lots. These synthesizers that have multiple sound sources like oscillators, noise generators, granular synths, samplers, wavetable, like if you can drag in an audio file and it generates a wavetable out of it. If it has like a variety of those sorts of things and built-in effects and a built-in modulation system, you can do glitch sound design in it. But I will be mostly using phase plant. But I'll probably go through at some point and do some glitch sound design in these different synthesizers, to show like how it can be done in different systems, and also just to explore what capabilities they might have that phase plant might not. Like Vital has the spectral morph knob. Oops. And on the random amplitude setting, it functions kind of like a bin scrambler, I think. Just like a spectral scrambler kind of thing. And randomly modulating this knob around can give some cool glitchy effects that you can't really replicate in phase plant, or at least not as easily and accessibly as you can in Vital. You could probably do something kind of similar with the filter table, but just different capabilities and different synthesizers. So let me just get into it with kind of starting with the most boring way of making glitchy sounds, which is with like a normal oscillator. I generally prefer working with like a granular synthesis, sampler, wavetable, that kind of thing, for glitch sound design. But you can still do it with a normal oscillator, and it's a good place to start because it's pretty straightforward, basic, and universal. Like just about any synthesizer is going to have a sawtooth oscillator, so it's broadly applicable. I will start out by messing with the phase, which at lower rates kind of creates like a popping, crackling kind of sound. But at higher rates, it's a lot noisier. Let me turn up the jitter on this. Although I will actually do this with a noise oscillator. You can get very noisy with it. But I just want enough to grid up the signal a little bit. Something like that. So then I will modulate. Well, okay, so the sync, let me turn this off. I like this point in the sync where it sort of breaks the waveform. It's some nice, very sharp tones in that area. So I will randomly modulate it up to about that point where it sort of breaks the waveform. And then let me put this back on. So at this point, it's just kind of like a noisy sawtooth. I will make something that you will see a lot of in this video. Oops. In this video and in any other videos in this series, which is a binary random modulator, which is just a random modulator mapped to a remap with on one of these binary settings where, 25%, 75%, 50%, or you can just set it to whatever you want. If you only want it to turn on whatever at a very high value just very occasionally, you can set it like that, but 50% will be fine here. But I generally find this like binary switching between high and low values of something works really well for glitchy sound design. So I will map this to the harmonic. Let me do that. Turn up this rate quite a bit. Yeah, I think that sort of jumping, stuttering kind of sound is good for glitch sound design. All right. Now I will add nonlinear filter on the metallic setting. This isn't, I'm not doing this to be like, here's how to design this exact sound, or just kind of general techniques and stuff. But this is not my first time, attempting to record this video, and I've kind of found the way that I've liked doing it. And, particularly this metallic mode on the nonlinear filter works really well for it, for, the sound that I'm trying to create here. I think it gives it a kind of mechanical sound. Like, you have different sort of flavors of glitch sounds. You have like corrupted kind of glitchy sounds like these here. Or, like glitchy UI kind of sounds where it's kind of what I would envision, like a virus sounding like a virus would mess with your computer in some way that would make, the audio sound strange. I don't know that's actually what happens, but, that's kind of what I imagine. Then you have like noisier, more electric kind of glitchy sounds. And then, which is, I guess, probably more along the lines of what I'm making here right now. And then you have more like mechanical glitchy sounds, like things that sound more like a physical machine malfunctioning, glitching out. Like a while back, I had a recording of like crumpling aluminum foil or something like that. And I put that in a granular synthesizer and did a bunch of random modulation and whatnot, and got this, very, very mechanical sound out of it. It sounded like some machine just freaking out and, malfunctioning mechanically. And I think this filter kind of gives a little bit of that kind of sound. Like it kind of sounds like a struggling hard drive that's skipping around and stuff. I think that's kind of the tone it gives. Oops. Like a struggling printer. Okay, so I'm going to make another one of these binary random modulators, although this one will not actually be binary. I'm gonna do this. Give it 3 levels. Oops. Okay. I think that's good enough. Okay, so next I will make a delay buffer, which is a very useful thing in glitch sound design. Like a lot of glitch tools have buffers built in, I think. Like Fracture. Oop. Glitch machines. I didn't know Air Windows had something called Fracture. What is that? Distortion? I guess so. That's kind of cool. I'll have to play around with that. But yeah, Fracture by Glitch Machines has built-in buffer thing like this. So how you make it? Quite simple to make in Snap Heap. Get a gain, a delay. You get one of these binary random modulators. Turn down the rate. That's probably good. Map it to macro. So when this is on, you want the gain at 0%, feedback at 100%, mix at 100%. So when this is on, the gain is set to 0%, so it's not getting any input signal from the synthesizer. The delay is, the feedback is set to 100%, so it's just looping whatever's in the delay. Mix is set to 100%, so you're not hearing any of the signal from the synthesizer. So it's just looping whatever is currently in the delay when the buffer turned on, for however long the buffer stays on, which gives a good glitchy effect. Now you can get a random modulator and have it modulate the delay time to change the buffer length dynamically, which can be fine. Yeah, that can work well. But I have generally found that you don't always want like a bunch of different randomly modulated things happening at different times individually. Like sometimes you want things to happen randomly, but for them to happen in sync with each other. So, for example, you might want the delay time to not change while the buffer is on. You might want it to just change when the buffer turns on. So each time the buffer turns on, it's set to a different length. So you would do that by turning this down and getting the output from the binary random modulator, setting it to the trigger thing on the random modulator. And so now whenever the buffer turns on, it changes the value of this. You can hear that. So that can work well. But what if you want it to not necessarily change every time the buffer turns on? What you can do then is just get another random modulator, turn that one down, have the output of this random modulator go to the trigger of that random modulator. Now have this modulate the time. So you can set the threshold however you want. 0.5 will be fine here. So now only when this random modulator goes from below 0.5 to above 0.5 will this random modulator change. So it happens in sync with the delay buffer turning on, but it doesn't happen every time, which is what I want here. Okay, that's good. So yeah, this delay buffer is very useful for glitch sound design. I already have one saved here, but you can save it as a preset and then just drop it in wherever you want. You could get another instance of Snap Heap and then load your delay buffer and then start running them in parallel with each other. Like this. Now this is probably a bit too noisy and chaotic, which I'll talk about more later on, but yeah, just things like that. It's a useful utility to have. You can also run them in serial, which can be cool. Oh, because these are turned down, that's why. But close that out. So since the mix is set to the lane, you can just put whatever else you want in this lane with it. So like you can put this frequency shifter on it. So now whenever the delay buffer is on, the signal from the delay buffer is getting frequency shifted. You can put a pitch shifter on there if you want. Yeah, whatever you want to turn on with the delay buffer. You could pan it. Oh, you know what you could do? You could copy this. And then no. Copy this one and have it go to a remap. This. And then have this call the pan. So now it's either center, all the way left, all the way right, whatever you want. Lots of options. Just whatever strikes your fancy. I'll get rid of this for now. I'll just put the frequency shifter on. So you can use the random binary modulators on whatever else you want too. Oh, it moved it. This happens every time for some reason. I end up moving it rather than copying it. So like I can get a chorus. And have it randomly turn on and off. Maybe a bit less often. And turn this on. Well, so you have this random switching between mono and stereo thing. Yeah, whatever little things can sort of make these little glitchy moments stand out can be good. Could get a bit crusher. Oh, actually, you know what? Maybe I'll save that for another video. There's something I like doing with the 3-band EQ, but I'll save that for the next video. So yeah, you can randomly turn the bit crush on and off. Oh, let me turn the jitter up. You don't always want jitter. Sometimes you want the random modulation to still happen at like equal intervals, but jitter can be quite good a lot of the time. Let me the bit crush. And then I could get another random modulator, have this trigger that, and have this mapped to the sample rate. So now each time the bit crush turns on, it's you know, reducing the sample rate to a different sample rate. Although now I think I might want to set this to 20. So this is all with one oscillator, or two oscillators technically, but I mean this one's just modulating that one. Only one oscillator that you're actively hearing. It's already a pretty complex sound. If you want to add more oscillators or sound sources in general, it can start getting a bit too noisy. Like, let me do something with this real quick. Okay, sure, whatever. Something like this. Some other texture that you want to add to the sound, just to add a bit more. If you play these at the same time, probably going to be a bit much. Just a bit too noisy, too muddy, too chaotic. The sounds start to blur together. You can't really hear their individual intricacies. So, this is, yet again, another use of the random binary modulator. You can get another one of these and turn this one down. This, turn this one down and turn this one up. So now it's switching between them randomly. So you're only ever hearing one of the generators, but it's switching between them randomly. It's just a way to give a little bit more clarity to the sound while still allowing you to add multiple voices, have, you know, additional layers of detail and complexity. Let me, oh, you know what? I'm gonna get, surprise, surprise, another random binary modulator. And I will roll the resonance of this filter with it. kind of hard to hear, seeing that there's so much else going on already. But I do like using a random binary modulator on filter resonance. Gives some nice results. But yeah, so I think that's probably about all I want to do in Faceplant itself. But there's a bit more that we can do to add a little extra sauce, which is OTT, especially 3 OTTs. I usually add 3 OTTs. OTT just works really great with glitchy sound design. It pulls out these like crunchy transients and stuff. It just makes the sound pop. Sometimes it gives you these nice little artifact kind of things at the end. It just pulls the sound together in a fantastic way. You can also add a bit of disperser or diopser. I usually put it before the OTT. The cool thing with the diopser is that it lets you go to some extreme levels with it. I find that doesn't tend to work super well here. It just, I don't know, blurs the sound too much. But at lower values, if it's gonna let me interact with it. At lower values, it can just give the sound a bit more like slappiness. And then once you have a sound, which I think this one, is about done. Thing you gotta do is just play it at different notes. Sometimes, like, you will get drastically different sounds depending on what note you play. Like, that's pretty cool. A bit different. A bit too noisy, I think. But yeah, you'll be amazed at how different the sounds can be played at different notes. But yeah, I think that's about it. Decent introduction. Sort of basic introduction, but I hope you enjoyed it, and I hope I will continue this series because there's a lot more to play with. Including things in the synthesizer and messing with files in hex editor and that kind of thing. Data moshing. Simon Hutchinson, I believe. Is that name? Yes, Simon Hutchinson has a great playlist on data moshing. Um, and that's actually, I think I played one of these earlier, but that's how I made these files, is messing with audio files in a hex editor. And he, shows you how to do that in one of his videos. So lots and lots of ways of making glitch sounds, and I hope to explore more of them in the future. All right, yeah, I guess that's about it. Hope you enjoyed.